Yeah, good morning, everyone. First of all, I'd like to give my thanks to Bill, Morgan, Mike, the organizers here, Jack as well, who's helping me. It's really a great honor for us to come and present. So my name is Sufyan Kazi. People call me Suf. It's just easier. It's got 3 letters. It's easy to pronounce. I work for Google in the UK. My background predominantly has been a technologist. I used to work at other cloud vendors in the past. And today, in today's talk, I will obviously mention this page. Maybe some of you have visited it, I'm not sure. Question I've got to ask first of all, how many of you were, when you saw the agenda and saw Google doing the keynote, were a little bit surprised? Okay, there's a few of you who are brave enough to say so. How many of you saw Google were talking today and were a little bit scared? So I presented at a few events, and typically there was, and I've got to get this out there in the open, I've got to kind of say this at the beginning. Typically the first question I get asked by people is, oh my God, Google, are you entering our industry? No. We are a technology company, I'm a technologist, and what I'm going to be talking about today is some of the technology we've built internally, why we built it, and also a little bit about my role. So I'm the asset management lead at Google in the UK. So why do we have an asset management lead? Why do I work and why do I talk to the buy side? So I'm going to share with you some of the conversations I've had across time and how we've been helping our clients. So Google, search engine. However, in the conversations I've been having with clients, typically they revolve around this broad theme, which is fundamentally organizations are facing a challenge. And it was great to see some of the challenges that Bill presented where being overwhelmed with data and being able to make the most of that data. What data is meaningful, what data is useful? Do we process every bit of information you have? Do we ignore certain bits of information? How do you pick and choose that? I'll be sharing with you, as I said, some of the examples of organizations we've worked with, and I love this comment from Resco, who are based in South Africa. Fundamentally, if you whittle this down, what Resco wanted to do was focus on what they do best. Something that they understand, which is serving their clients and delivering alpha, and not focusing on IT. They didn't want to become an IT vendor. They didn't want to spend time looking at servers and DevOps and patching operating systems and making machines were running. That's not what they wanted to achieve, and that's hopefully, I'll share with you later, something that they achieved with Google. Now, a little bit of background. Our mission always has and always will be to organize the world's information and make it universally accessible. Now, our founders, Larry Page and Sergey, when they set out Google's mission years ago, iterated on that. And Larry specifically felt, for us to be a search engine, it was more than just having a page where you could enter information. How many of you remember internet search before Google? Good. That's the correct answer, thank you. I have presented at conferences or meetings where, obviously predominantly it's been a younger audience where a lot of people haven't heard of search engines outside of Google. They did exist. My personal favorites in the past, I used to use Alta Vista, sometimes Lycos, Excite. So what set us apart? What differentiated us? And fundamentally, we went down an approach or a paradigm of, I think what we saw in the market was traditional search engines had taken the approach of an encyclopedia. If you needed to look up information in an encyclopedia, you would go to an index book, you would look up your entry, find which volume was your entry was defined in, find which page, and then go and find that reference book. And search engines in the late 90s, early 2000s, predominantly took that approach. Let's scour and mine the entire World Wide Web, and let's build a sort of reverse index catalog. And our philosophy was different. Well, how do we trust a website is actually saying what it says it's talking about? Why don't we look at what other people are saying about websites when they link to them, when they refer to them? Why don't we monitor, as people are clicking on searches or search results, how many people are actually following searches? So adding a bit more intelligence. Why don't we start building technology that can parse and analyze a website content and to get a better understanding of what's in there? And something that could help us understand users as they start typing their searches in, where we could factor in when they're searching, why they're searching, what else is happening at that same time. So the perfect search engine for us is something which understood exactly what you are trying to search for and could present the right material back to you. So we effectively went on a journey as a technology firm, building great technology, improving our capabilities for processing data, and going beyond and really investing in machine learning and AI. So today I'm going to talk about a bit of our history, our foundations, how we built Google Search, how we're exposing that working with clients in the buy side, and some of the examples of success stories we've had. So if we begin with the foundations. How many of you have heard of Jeff Dean? I was expecting that, okay. Jeff was one of our original employees. I think it was definitely in the early tens of employees. When he joined Google, he definitely didn't have this mantra, let's make computing great again, but I think it's appropriate, it fits. The state of computing or the state of the world at the time wasn't really ready for processing large amounts of information. And what Jeff helped us do was tackle the challenge of kind of moving away from the mindset of data is complex. And actually, the task of processing information can just be thought of as a compute job, a job that needs scheduling, and a job that needs monitoring. And if we could break it down to jobs, he built frameworks which allowed us to free our developers to focus on ideas and real challenges to solutions to industry challenges. So fundamentally, he realized that for us to scan the entire World Wide Web would take us a lot of time, would take us one computer, 3 months. That's not going to give us a really powerful web search engine. So he sought to discover new ways to parallelize computing, to process and store lots of data at pretty fast speeds. And he worked with teams internally with Google, and we did something which was pretty unique at the time. Our ideas and our best practices we documented as white papers and shared them with the world. Early white papers were our file system white papers. We had white papers on something called MapReduce, which is now at the heart of technologies like Hadoop, etc. So we shared those ideas externally. Internally, we took those ideas and we went nuts. We built great tech to run those ideas at scale. When we began as a company, we were famous for doing things like monitoring financial pages of newspapers to discover companies who had gone bankrupt, because we could use their office space because it was bound to be cheap. And we built our own computers by taking pieces of technology and sticking them together with kind of cork boards and whatever we could find. And we've obviously progressed beyond that. But the fundamental concepts are still the same. So for example, we build our servers, or we get our servers from the 5th biggest server manufacturer in the world. Turns out to be Google. Because we construct so many servers, the volume that we're producing just really kind of puts us high up there. And there's a few other kind of crazy stats. I think we're one of the world's biggest telcos, but we're not a telco company. We're one of the world's biggest server manufacturers, where we don't sell servers. There's some weird facts about construction companies. I think we've got one of the biggest construction companies because of the amount of construction we do. But the point I'm trying to make, at least on this slide, is for us to solve the challenge of mining information and delivering insights on that information at extreme pace, we needed to think about 3 basic compute problems: compute power, disk storage, and network. So internally, we built something called Borg. Borg is our internal cluster management system for handling compute jobs. Now, I'm not going to bore you with the science, but basically, when a team one day in Google said, okay, search is interesting, why don't we start looking at maps? Why don't we start looking at traffic data? Why don't we start looking at trends of where people are based on their mobile phone location, so we could give real-time statistics on how busy a specific shop is at a time of day, etc. These were ideas that needed a lot of compute to process information as needed. Borg helps us do that. It allows the developers not to worry about the infrastructure behind the scenes. They simply develop the code and issue it as jobs to Borg. And Borg simply runs a job, for example, collate a bit of traffic, and then turns off the compute. And that compute only runs when needed. And the data which is produced is then written to our Colossus file system. And Colossus is pretty impressive. It must be, because it's called Colossus, right? It has the capability to store information at significant speeds, So we can write, and I'm going to refer to my notes because my memory isn't so great, but we can write a huge amount of information in parallel. I think 10,000 machines simultaneously can read and write data at 10 gigabits per second, which is pretty fast if any of those numbers confuse you. And then attaching our storage to our computers is our internal network, and that's our Jupyter network. We have a notion internally of a petabit bisectional bandwidth, which effectively means it's extremely fast. I think several thousand machines can simultaneously transfer data gigabits per second at the same time. So if you put all these factors together, we can harness a lot of information, we can process that really quickly and share that information between computers in parallel, which is pretty powerful. How does that apply and how is that useful to the world? Well, I'll get onto that. So we built great data centers, awesome. The next challenge we had was connecting those data centers so that the speeds between them was also equally low. So we started laying cables across the oceans. I think the most recent cable was a few months ago, was down to Brazil somewhere. We have a navy guarding our cables. It's a grand navy, it has 2 ships. And fundamentally, because these cables are our own, effectively we know the traffic which is going over them, which is pretty secure. We know that the latency between our data centers is pretty low. It allows us to build some really powerful real-time systems, which are being used for extremely useful scenarios. Effectively it means, for example, I could take a server in the UK and I could ping a server in Australia within 200 to 300 milliseconds. Effectively, the only thing holding us back is the speed of light. So we built this great compute, we built our great foundations, and that allowed us to develop and innovate internally. It allowed us to think more about how we're going to better use artificial intelligence, how to improve the capabilities and processing of our search so it reflected the needs of users and could interpret their use cases. We even use machine learning to improve the way we run our data centers. So I believe we're the only cloud provider or compute provider which is recognized by Greenpeace for the environmental or lack of environmental impact our data centers have. So they run at a 40% improved efficiency than before we applied machine learning to analyze our cooling fans and analyze our power usage. We were pretty surprised when we turned the results on. So there's this famous graph which we will show in our slides where we turned the machine learning on, saw the saving and thought there must be something wrong here, turned it off again and suddenly the usage went up. So it's pretty impressive stuff. So for us, using machine learning is not complex. Applying it correctly is not complex. And this is where we, or at least myself, have been involved with talking to the buy side and talking to asset managers about how to use our capabilities to give them machine learning insights or capabilities that they weren't able to do beforehand. Okay, so I hope that was useful. A little bit more about the work we're doing or the kinds of technologies we're sharing with the buy-side firms. I think this debate has been going on for some time, specifically in this industry, where do we kind of draw the line between algorithmic trading and machines kind of running everything versus a human kind of having some kind of impact. Definitely something we share. We think there always needs to be some kind of human involvement. Machines can only do so much. Effectively, they can automate mundane tasks, but there needs to be an element of intelligence. So we always try to build our technology where there's an element of collaboration between people and between the information provided to people and the people themselves. So it was great to see collaboration mentioned in Bill's slide early on as kind of a challenge area. So if I look at some of the things we're doing, the first thing, or the first area of conversation I have with clients is about time and wasting of time. So this is independent research done by McKinsey, where they discovered that approximately 20% of a typical employee's time is spent looking for information internally within that organization. So within your CRM systems, within your ERP systems, within your HR systems, trying to locate and find something useful or applicable to you on that particular day. I myself, I think 20% is a bit low. I think I spend more time than that trying to search for information. But the interesting stat is the one next to it, which is because I couldn't find the information I wanted, I probably waste another 38% of my time. I don't know who comes up, where these metrics are based, but another 38% of my time trying to rebuild the information or trying to rebuild a deck or rebuild a document that actually existed. I just couldn't find it. So again, there's a double waste. So Google was thinking about this, and this is a challenge which is not just applicable to the buy side or the sell side, but it's across all the industries we work with. And we've shared our search capabilities with organizations as a hybrid solution, which could be run on-prem or off-prem. And effectively, it allows you to use our search capabilities connected to your internal systems. So on the left here, basically, there are connectors which you would deploy in your existing system. They can mine and trawl through your ERP or CRM systems. Your data is obviously protected and restricted to yourself. And then you could leverage Google search to get the insights. And that search could be surfaced within your own internal systems. So that's a great simplistic use case. And it would be natural for Google to be doing something with search. But what are we doing in this industry? And what are we seeing in this industry? So just take a snippet from an article last year from the FT about the rise of quantitative research. And this is definitely an area I'm kind of being increasingly involved with. It's not the only area, it's part of my role. But if I kind of elaborate a bit more on this, the conversations I've been having with customers are kind of revolve around these broad areas or these broad challenges. And I think some of this overlapped with what we saw earlier on. There's increasingly a large amount of data which is available that asset managers and buy-side firms want to make the most of. Increasingly more and more decisions need to be made about what data is important. You want to be able to do unlimited hypothesis testing to try something out, see if it's the appropriate strategy, and if not, discard it and try another one. But you want to be able to do this based on same-day research, moving to a more intraday processing rather than your traditional batch waiting a few days. And in the conversations I've been having with organizations, typically challenges are, we have an idea, but we can't yet try that idea out because our compute is locked up by some other team. We've only got finite capacity. Or we tried something and it took several hours and then we have to wait until that runs before we can complete. And that's some of the areas where we're helping alleviate those challenges. Now, a simple architecture for solving that problem on Google is pretty easy to do. I'm not going to go into the technical details, but fundamentally what this slide says here is that you could spin up computers pretty much to an unlimited extent on Google Cloud to perform the same functions or similar functions to grid compute that you need or you use nowadays. And the benefits of doing this obviously are, from a cost perspective, it's an ephemeral cost in some cases. You spin up the computers needed and then discard it when you don't need it. Because underlying behind the scenes is using our Borg and our Colossus file system is leveraging the same technology we're using internally. The other advantages are obviously each researcher can have their own cluster compute. They're not limited by having to wait in a queue. And the other obviously major advantage here is this is a fundamental classic switch to cloud means you're moving away from the huge capital expenditure of investing and running your own data center to just a normal operating expense of paying for compute when you need it and then not paying when it's not running. And you're simply paying a low overall cost for your data that's stored in the cloud. So definitely this is a use case we've seen adopted across the industry. And if I look at some of the 5 kind of key conversations I have, and I'm not going to go through all 5 in case all of you are worried, what this solves is how do I modernize my current infrastructure? How do I improve what I have and get something a bit better? And it's an easy sort of first step, an easy stage 1 of the journey. Increasingly though, the assistance I'm providing is more the bigger pictures. Well, okay, you can help me run compute, but what about actually giving me better insights or better understanding of my data, helping me analyze and get more conclusions or generate more hypotheses? So we have a lot of technologies. One that frequently comes up for me when I'm talking to customers is something that we called BigQuery. It's a phenomenal name. I think we were really kind of winning that day in terms of inventiveness. So it's there to query a lot of data. It's a data warehouse. It runs on our cloud using our infrastructure behind the scenes. And broadly what that means is, and I think Bill alluded to this, and I've heard this a lot, there's concern that, okay, how do we make data processing easier? There's a talent shortage. What if we could simplify the barriers to entry? Our data warehouse is just using regular SQL, the same SQL that we'd use with any other database. However, it benefits from having our infrastructure behind the scenes. So it runs pretty fast. You can run silly queries like this if you really wanted to. This is a query running in one of our sample data sets. It's a copy of Wikipedia. It's 100 billion rows, and you could do a really silly query on that and we'd get your results back in 60 seconds. Which is, okay, interesting, but how does that apply in this industry? Well, I've worked with organizations who are dealing with years and years worth of financial instruments, tick history data. By loading into BigQuery, they're able to return and do reports or processing in minutes rather than the days that they're normally used to. And it's definitely given them a benefit or a huge step up in the way they work, in the way they operate. So big data processing, it's there, and BigQuery may be the answer, may not be the answer, but it's something I just wanted to share with you. The next stage is, okay, machine learning. How do I then move to a more predictive or more sort of next stage of analysis of my data? So what is machine learning? I stole this from a colleague of mine. Some people, I don't know if everyone here is familiar with machine learning. I'm not a machine learning expert, I'm not a data scientist, but it helped me to try and understand. And fundamentally, machine learning, it's a bit like, let's say you go on holiday and you've got your suitcase and it's got a combination lock on it, but you forgot the combination lock. So how do you solve that problem? Well, apart from smashing that suitcase up into pieces, you could try 000 and see if it unlocks. And if it doesn't work, well, let's try 001. And if it doesn't, let's try again, and on and on and on and on. And so to some people, machine learning is a bit like that. Let's try all the combinations and let's try and learn what the result is. And if we didn't learn, let's kind of tweak it and adjust it. And I think machine learning is a bit more than that. It's a bit more sophisticated. It's effectively, there's many flavors. It's a branch of AI. It's effectively a way of teaching computers to determine or work out an answer by giving it a large set of data and giving it a set of features which it can use to kind of build patterns. So using my example, the patterns would be, I've got a couple of numbers. It's probably not going to be 000. It's probably more likely to be something to do with my birthday or my wife's anniversary, using that kind of evidence to kind of guide the decision making. What I've experienced, though, in some of the conversations I've had, and actually I found in this industry, machine learning is not a new concept. It's been going on for years, and in fact, Google isn't inventing something new here, but the skills required to apply it correctly are hard to find. And if you do have those skills, maybe they are embedded within a programmer or data scientist who perhaps doesn't understand the industry. So getting that broad kind of coverage of someone who really can understand and interpret signals and really generate insights is perhaps difficult to find. And Bill, you alluded to it, and I laughed, and I've heard this before. Often the criticism is, well, the really good data scientists are now working at Google. So what are we doing? Well, what we're doing is we're trying to make it easier for organizations who can't obtain data scientists or find it a struggle. So I'd like to share with you the story of, I forgot his name, I do apologize, Japanese family. One of these individuals taught himself how to do machine learning. I wonder if any of you could guess which one it was. Yeah. So obviously it was the son. So we've got a parent, a mother and father who run a cucumber farm in Japan, and their son works for a Japanese automotive car manufacturer. He's a systems designer. Didn't know machine learning before then. And interestingly, hearing the challenge they had was very similar to the challenge that Resco mentioned earlier on. where they wanted to focus on farming cucumbers, not on some of the logistics or the hard kind of tech behind the scenes. And cucumber farming, as I discovered reading this case study, is a lot more complicated than I thought it was. So there are different classes of cucumber, and those classes attract a different price. In fact, there are 9 classes, and the classes were driven by the freshness of the cucumber, the length of the cucumber, the shape of the cucumber, the smell, all these different features. And the mother of the family, she would spend 8 hours a day sorting the cucumbers into those different classifications. And if she incorrectly sorted, then they could miss out on potential high-value cucumber sales. So what the son did was he effectively taught himself machine learning by using something called TensorFlow. I don't know if any of you have heard of TensorFlow. Okay, good. So TensorFlow is a machine learning framework from Google. It's open source. You can use it to run machine learning on any kind of platform. Running it on Google Cloud gives you other benefits as well, which I can talk about later. So he taught himself how to use TensorFlow to build a model, a machine, which unfortunately this video isn't playing, but basically it shows the cucumbers passing along, cameras taking pictures, and then his machine learning model effectively automatically classifies the cucumber, freeing up his mum to do QA, quality control, and actually spend more time picking up other cucumbers. So I realize that all of us here aren't in the cucumber industry, so how does that really help you? Well, how many of you have seen this picture before? Wow, I'm surprised. Put your hands up if you think it's Tom Hanks. Unfortunately, it's Bill Murray. So Bill Murray can tell you that, Tom Hanks can tell you that, and Google Photos can tell you that, as probably have a similar technology. So how do we apply this kind of machine learning? You know, how could the Japanese farmer kind of use text from Google to actually just point it at the cucumbers and simplify the challenge of having to learn machine learning from scratch? So what we've done at Google is we realize we've got a lot of tech, which you're probably familiar with. So if you take the ability to look at an image and combine that with translating some text, you can combine a couple of different features which you're probably used to as a consumer. And we've made them available as APIs. And those APIs are increasingly being used by some of the customers I worked with. So we have a Vision API, which is for looking at images and pulling out textual content from it. And one of the use cases, for example, is simplifying the manually intensive processes of dealing with inbound invoices and purchase orders and automating the processing of that. Kind of combining that with Blue Prism or RPA type capabilities. Equally, our APIs could be combined. So for example, if you were to extract text from content or from images, you could then run it through natural language API. And that API would tell you about entities, people within that it could understand, locations, could tell you about sentiment. And I'm using this word API fundamentally to say that what these are just simple lines, simple calls to Google that you could embed within a program or within a RPA type interface. So it negates you having to build that machine learning intelligence. You just can leverage what's already built. We've seen it used for building early warning signals for detecting trends in the market. We've seen it for transcribing text, for example, for transcribing earnings calls in real time, or for perhaps for doing trader surveillance, for kind of detecting fraudulent trading, etc. So broadly speaking, the Japanese farmer was using our machine learning technology on this end of the spectrum, which is there for the people who have core data science capabilities and want to be able to use our technologies to build something really exciting from scratch. The other use case is on this side of the spectrum where perhaps you just want a chatbot, so you could use Dialogflow. Or you just want the capability for processing information, you just want to use one of our APIs. They're there and they're available. And then in the middle ground, we have something we announced last year called AutoML. That's really interesting. AutoML is taking our machine learning and our capabilities and transferring that to you so you can combine that with your data. So what do I mean by that is that where we may scan some text in a document and identify it generically as a boat or something random. You could actually apply your own semantics or your own linguistic specific to your industry or your company. And that kind of really makes it more powerful. And we're expanding that features quite rapidly. So 3 broad ways of doing machine learning on Google Cloud, but it's not the only way. There is a 4th way. In fact, there's probably multiple other ways. So something else I just wanted to surface is something we call BigQuery ML. So I mentioned BigQuery before. It's a data warehouse. It's a database. And I mentioned that machine learning is about giving computers a large amount of data and letting them train over time. Well, if you're going to store a large amount of data, for example, in BigQuery, in our data warehouse, what we realized at Google is, wouldn't it be great is if you could just tell BigQuery to train itself over your data. If you could tell BigQuery to spend time to say, hey, I've got these 30 years worth of tick history or financial instruments. Can you look at all these features, all these columns, and begin to build some insights? And you can construct that as a simple SQL statement. And once that training is completed, then you just reference it in a report or in whatever capability you want. So again, this reduces the barriers we feel for achieving or making the most of machine learning. And that's why some of our customers are really helping to democratize data science within their organization. It isn't necessarily just a need to hire experts. You can kind of lower the entry barriers, if that makes sense. So I've talked a lot about our technology and a lot of our capabilities, but obviously the most important bit is data and the kinds of data that can be used. I've mentioned about market data. We're increasingly working or trying to work with market data providers to make that available as data which can be exposed directly in BigQuery. We obviously have data which you're familiar with, and this is available to anyone in any industry. So as a developer, you could access some of our maps information using our APIs. So for example, I've seen that used by some organizations to help them make decisions based on locations. For example, what shops are located near a specific group of customers, maybe to help them with the impact of a merger of 2 organizations. And alternative data, I mentioned before, we have a lot of APIs which are capable of processing speech, text, image. Now, as with any technology, and especially with alternate data, a decision needs to be made of how valuable it is, but to process and harness that data is, I think, simplified using our technology. For example, here I've mentioned at the bottom Descartes Labs. Descartes Labs based in the US. One of the challenges they had was analyzing crop data in the US to predict yield. And so they used Google Tech to save them from having to invest in a lot of computing power to process that information, which was a real benefit to them. And if I look at the quant challenge, and hopefully this is kind of a similar scenario to you, a lot of the conversations I have with organizations is, what is the length of time this cycle takes within your industry or your specific use case? Where we're trying to help is to reduce that window and allow you to do more of those windows in parallel. So in some of the use cases I've seen or some of the organizations I've visited, typically their quant research model or quant interface kind of looks like this. They have their own data center with a couple of computers in it. The team that needs to use it needs a queue, as I mentioned before. They have some magic which someone in some team has built, and that understands how to take the data in. And the data is kind of retrieved or inputted using traditional protocols, something like FTP between different providers or some kind of API call. And then the analysis tool is the analysis tool, which is, I think, the most prevalent, which is Microsoft Excel. So what I don't see here is cutting-edge tech, and what I don't see here is collaboration. So I put it to you or suggest an alternative, obviously a very Google-centric alternative. There are different ways of solving the same problem. If we put BigQuery at the heart of this, some immediate benefits are obviously you're getting the reliability and the failover and the durability that BigQuery offers because it's built on Borg and built on Colossus and Jupyter. You get the capability to stream data in real time, So as data is streamed into BigQuery, it can be surfaced in seconds as soon as it sort of enters. You can analyze and process your data using open source technologies, again, reducing the skills and the technical barriers to entry. You can use common commercial products for analyzing and looking at your data who've built connectors for BigQuery. You could even, if you wanted to use Google Sheets to analyze your data. So last week we announced integration between Sheets and Big Sheets. Again, impressive naming scheme there. And Big Sheets effectively allows you to analyze 10,000 rows of data from BigQuery in a single spreadsheet. But you also get the normal benefits of Google Sheets where multiple people are collaborating together, working on a document in real time, rather than a traditional workflow, which is, okay, I've done something, I'm going to save it as version 0.1 and then email it to someone who's going to send it back to me as version 0.2 and on and on and on. Perhaps something that's kind of coming across your mind is how secure is all of this? And that's a standard concern for anyone thinking about the cloud journey. I can't verbally mention the customer's name here on stage, but if you were to Google Google Cloud FinTech Security, you'd see some organizations in this industry talking about what they've done on Google Cloud and how they've secured their workloads. Fundamentally protecting leak of information or leak of IP. And they've been able to kind of mitigate that risk pretty well. And we've got all the standard certifications you would expect. So, using Google Cloud liberates you. It is a bit like having your own Google. So what does that mean in reality? You're just going to skip forward. If I kind of talk about some of the examples of customers we worked with. Azimut, a company based in Italy, had a standard challenge where they wanted to be able to process market data in real time and share their insights across their global branches. And so they took the decision to go with a certain cloud vendor and didn't feel quite that they were getting the performance they expected, and so they switched to Google. With Google, they saw the huge performance gains. They saw cost savings of 35%. And overall, they would be able to reduce a lot of processes down to minutes, which previously was taking a couple of days. So really interesting use case. I'm not going to spend too much time talking about it. You can read more about it online, or I'm going to be available. One other example I'll share is the Manor partnership, who are based in New York. I love the bit I've highlighted in red here, where again it's reinforcing they're now focusing on what is valuable to them, rather than the boring compute infrastructure behind the scenes. So they get market data from Bloomberg and Refinitiv and lots of other providers, and found it was easier for them to process that information using our tech. And the last use case I will refer to, I'll come back full circle to Resco, who I mentioned early on in the day. Once they started using Google Cloud, it really hit off and really kind of started an upwards trend in their firm. So they began in 2011 simply using our Google Collaboration Suite, G Suite. They then began investigating the use of BigQuery and saw the benefits I discussed, where they would be able to process data, reducing man hours internally, through automating a lot of tasks, especially as they moved through data flow. But then, interestingly, near the end, as their confidence grew, they suddenly started delving in real data science themselves. And they built something which they call Alice OS, Alternative Income Trading Strategy Operating System. It's basically machine learning which processes their years of data and gives traders insights and ideas to allow the traders to use as they see fit. It's kind of like almost like an internal recommendations engine. And now that I've had that in place for a few years, or for a year or so, they're actually allowing it to do some automated trades within certain constraints because they feel confident in what it can deliver. So it's interesting to see their journey over time and how they've really adapted. So once again, it was. I'm really glad I had the chance to speak to you today. I'm going to be around sort of most of this morning, and my colleague who is at the back, Martin, is also available. To reinforce our mission always has been to organize the world's information and make it universally accessible. Google Cloud is an extension of that Google mission, and it's geared towards the enterprise. And I really hope this was a useful conversation, a useful chat. I really appreciate your time. Thank you so much.